Good evening. I'm Eric Ward, Vice President for Public Programs at the Linda Hall Library. Thank you for joining us tonight for Life on Mars, a Cultural History with Professor Jordan Bimm. Tonight's talk is part of our ongoing series complementing our exhibition Life Beyond Earth that explores the scientific search for extraterrestrial life from the 16th century to present. The exhibition is free and will be on view at the Linda Hall Library through June 2025. Visit lindahall.org for more information. Now, within our solar system, Mars has always been at the forefront of humanity's search for alien life. And we're honored to have Dr. Jordan Bimm join us tonight to talk about this fascinating history of our galactic neighbor. Dr. Bimm is Assistant Instructional Professor of Science Communication and Public Discourse at the University of Chicago. Originally from Toronto, Canada, he's an historian of science focused on U.S. space exploration who specializes in space medicine and astrobiology. His research investigates big questions like who should go to space and what happens if we discover extraterrestrial life. Professor Bimm is also an old friend of the Linda Hall Library. He was a research fellow here in residence in 2019. And his work has been published in numerous academic journals and popularized in the New York Times, Scientific American, and The Atlantic, among other publications. At the University of Chicago, he teaches courses on science communication, as well as the history of science and space exploration. Dr. Bimm, it's great to see you again, and welcome back, at least virtually, to the Linda Hall Library.
Thanks so much, Eric. It's great to be with you all tonight.
Yeah, this is Mars is just a fascinating topic, and I know there's a long history of the search for life on Mars, so I'll just turn it over to you.
Yeah, we're going to get into it. All right, I'm going to go ahead and share my screen now. Is that coming through over there?
Yes, yes.
Okay, great. Well, thank you, everyone, for tuning in tonight. I really appreciate you being here. Let's get started. Is there life on Mars? This question has fascinated humans for thousands of years. Our collective desire to know whether life or other intelligent beings exist beyond the Earth is very, very old. In some form or another, this question, this wonder about the nature of the universe and about reality itself, appears in written records from multiple cultures, going back to the very dawn of recorded history. This means that we don't know when humans first started asking this fundamental question or why they started asking it. We can only say that it has been with us for a long, long time. And it remains unanswered. We still do not know whether life or intelligent beings exist beyond the Earth, on Mars or any place else for that matter. Even as national space agencies and private companies rapidly expand our scientific and technological capabilities to search, we still know of only one place in the universe where life exists: our Earth. Is there life on Mars? Tonight we are here not to answer this question, nor to get an update on the latest findings. Instead, we are here to understand what it means to ask the question, is there life on Mars? Like every other aspect of human culture, our commitment to this question is not static, nor is it neutral. It changes over time. It is given shape by the earthly problems of the day. Asking, is there life on Mars, means something different today than it did to our ancient ancestors, who first noticed a red star wandering in the night sky. Indeed, it means something different today than it did even 100 years ago or 50 years ago. Tonight, we unpack, examine, and historicize our fascination with the red planet and the possibility of life. We do so to understand hidden dimensions to the question and the ensuing conversation. What are we really talking about when we talk about life on Mars? Different examples from the past help us see the specificity of the present and even the future with added clarity, and hopefully in a productive new light. To understand what it means to ask, Is There Life on Mars?" This lecture will focus on 3 moments in the history of Mars exploration, recent in the grand scheme of things, but covering over a century of increasing activity. First, we will learn about the American astronomer Percival Lowell. Starting in 1894, he popularized his belief in an advanced technological civilization on Mars. Second, we will jump ahead to the 1950s, the early Cold War, and the dawn of the space age. Here we find German rocket scientist Wernher von Braun planning a US military-led expedition to Mars. The third historical moment we will examine takes place in the 1960s. Here we find NASA researchers musing about microbial life on Mars, motivated not by military operations, but by the more familiar goal of scientific exploration and discovery. These 3 moments will demonstrate not only how ideas about what kinds of life might be on Mars change over time, they show us how the question of life on Mars fits into wider concerns, projects, and debates happening right here on Earth. In each, different ideas, different plans, and even different worldviews are at stake. Because the question of life beyond Earth is so old, we often think of it as timeless. My goal here tonight is to give you an appreciation for how this is not the case. The meaning of the question, "Is there life on Mars?" is not timeless and unchanging, quite the opposite. It is ever evolving and dynamic. Before we delve into our 3 fascinating cultural history case studies, which focus on some fantastical visions of what humans in the past thought Mars was like, let's establish a picture of the planet that really exists out there, forth from the sun. Whereas cultural histories focus on humans and their ideas about an object, natural history focuses on the object itself. For Mars, a natural history is a story of how its geology and environment have changed over time. This brief natural history of Mars will answer some basic questions about the planet's physical properties and set the stage, quite literally, for our cultural histories that will follow. Some 4.6 billion years ago, the planet Mars, along with Earth and the other planets of the solar system, emerged from a primordial swirl of gas and dust surrounding the young sun. Mars took shape as a rocky world with towering volcanoes, a thick atmosphere, and flowing rivers. Its molten core generated a magnetic field that shielded the planet, preserving its atmosphere and allowing water to exist in a liquid state on the surface. We can read this natural history of liquid water on the surface in geological formations left behind, including dry riverbeds and deltas, imaged by robotic spacecraft in orbit and rovers on the surface. But around 3 billion years ago, Mars's molten core cooled, and the protective magnetic field it produced faded. This allowed solar winds to slowly strip away most of Mars's atmosphere. The thin atmosphere that remained could no longer produce enough pressure to maintain water in a liquid state on the surface. So 3 billion years ago, Mars was a much warmer and wetter place. But since then, Mars has existed in roughly the state we find it in today, a freezing, low-pressure desert bathed in radiation. The average temperature on the surface of Mars today is around negative 80 degrees Fahrenheit. Mars's atmosphere, once thick, is now a mere wisp of gases compared to Earth's. On Earth, at sea level, we experience a pressure of 14.7 pounds per square inch. On the surface of Mars, the pressure is far, far less, not 14.7 psi, but 0.08 psi, just 1% of Earth's atmosphere. For comparison, to experience this low level of pressure on Earth, you would need to ascend to the equivalent of 80,000 feet in altitude. That's 3 times as high as Mount Everest. On Earth, our atmosphere is comprised of 78.8% nitrogen and 21% oxygen. On Mars, the much thinner atmosphere is 95% carbon dioxide. For a human to stand on the surface of Mars today would require the same level of protection as standing on the moon or floating out in space, a totally sealed, pressurized spacesuit. Today, the planet Mars is known for three prominent geological features. The northern polar ice cap, which appears white and is comprised of frozen water and frozen carbon dioxide, and is large enough to be visible by telescope from Earth. Mars also has the tallest mountain in the solar system, a massive volcano known as Olympus Mons. And this giant scar on the surface is the largest canyon in the solar system, called Valles Marineris. The final crucial aspect of Mars's natural history is its orbit in relationship to Earth's. And this feature of natural history has big effects for our cultural histories that will follow. To understand this relationship between the orbits of Earth and Mars, imagine Earth and Mars are two runners running around an oval track with the sun at the center. Earth on the inner lane runs faster, while Mars on the outer lane moves more slowly. As Earth speeds ahead, it eventually laps Mars, catching up to it from behind. At the moment Earth overtakes Mars and they are side by side on the track, we reach what astronomers call the opposition of Mars. It's called the opposition because, from Earth's perspective, Mars is on the exact opposite side from the Sun. If the runner we think of as Earth looked directly to their left, they would see the sun in the center of the running track. To see Mars, the runner we call Earth would need to look in the exact opposite direction, to their right. This is why, when Earth and Mars are side by side, astronomers call it the opposition of Mars. Mars is on the opposite side of Earth from the sun. So the opposition is when Earth and Mars are at their closest distance in their orbital journeys around the sun. This occurs like clockwork once every 26 months, or roughly once every 2 years. This orbital relationship has deeply influenced cultural perceptions of Mars. In the 1600s, when astronomers like Galileo and Christian Huygens first turned their telescopes skyward to observe celestial objects, they realized that the opposition of Mars was the best chance to observe the red planet. Imagine the runners on the track. It is much easier to see your companion when you are passing by them compared to when you are on the opposite side of the track from them. Early telescope astronomers understood this, and they made sure to take advantage of this special window of opportunity once every 26 months. In this way, the orbits of Earth and Mars produce a regular and predictable uptick in astronomical and cultural public interest in Mars. As a historian, this is very helpful because if you want to find old newspaper articles about Mars, a good place to start is to calculate the opposition and then look back near those dates. The opposition of Mars still has this effect today. Most importantly, it now determines the launch window for sending spacecraft to Mars. For example, in early 2021, 3 space probes arrived at Mars: NASA's Perseverance rover, China's Zhurong rover, and the United Arab Emirates' Misabar Al-Ammar orbiter. All 3 of these probes were launched in July and August 2020, just ahead of the opposition, in anticipation of this closest pass between Earth and Mars. Future missions, including possible human missions to Mars, as well as their resupply missions, will also be governed by this natural timing of the planets. Now, back in the 17th, 18th, and 19th centuries, when the exploration of Mars was carried out by looking through optical telescopes, the red planet remained a mysterious object. Even under the best conditions, on a clear night, during the opposition with Mars at its closest, astronomers would only see it as a tiny reddish disk that would phase in and out of focus due to the distorting effects of Earth's atmosphere. They could, in rare moments of clarity, glimpse only the most basic surface features, the northern polar ice cap, for instance. Even as telescopes became larger and larger, so much of Mars remained ambiguous and subject to speculation. Here we can see a map of Mars from the collection at the Linda Hall Library, produced by German astronomers Beer and Madler in the year 1837. And yes, it was produced in 1837 because that year there was an opposition of Mars. Now today, because we have a small fleet of robotic spacecraft at Mars that have snapped millions of high-res, crisp images like this one of the surface, and stitched together orbital photographic maps like this one, and provided clear views of the whole of Mars, it's easy for us today to forget just how mysterious and just how ambiguous Mars was even as little as 70 years ago. To get a sense of this, let's rewind from 2024, the version we see today, back in time 70 years to 1954. In the year 1954, this was the very best image astronomers could make of Mars. This was it. This photograph was taken using one of the most powerful Earth-based telescopes under the most favorable seeing conditions during the opposition of 1954. It's blurry. You can't see the surface. It's impossible to tell what might be down there. The only thing this photo really does show clearly is just how much we still had to learn about Mars, even just 70 years ago. Mars was still a very mysterious place, with plenty of scientific debate about whether or not we would discover anything like life on the surface. Now we can turn to our first episode in the cultural history of life on Mars, Percival Lowell and ideas about a civilization. This case begins, as many Martian developments do, with an opposition of Mars. The Great Opposition of 1877, as it was known. In 1877, Mars came into opposition and astronomers trained their telescopes on the red planet. Italian astronomer Giovanni Schiaparelli viewed Mars through his telescope and published a novel claim that he could see a complex network of straight lines on the surface of the planet. He produced detailed maps depicting these lines, which we see here, but he stopped short of saying anything about what these lines were or what might have caused them. He didn't say whether he thought that they were natural or artificial features. Despite the fact that few could reproduce his sightings, his claims ignited a Victorian-era sensation about possible life on Mars. And if you look at maps of Mars produced between 1877 and 1965, you will often see this distinct cobweb-like pattern of lines. This Mars mania, beginning in 1877, solidified Mars as special amongst the other planets of the solar system in the minds of astronomers and the public. The Great Opposition of 1877 is when Mars attained its special place of interest in Western scientific culture that it still enjoys today. Only after 1877 did astronomers begin to specialize in Mars. Now, caught up in all of this buzz about apparent lines on the surface of Mars was a Harvard-trained astronomer named Percival Lowell, who was then a professor of astronomy at MIT. Percival Lowell came from wealth, and in 1894 he used his family's fortune to construct an astronomical observatory in Flagstaff, Arizona, specifically to study the lines that some had reported seeing on Mars. After looking through his own massive telescope, Lowell took the extra step of now claiming that he understood the origin of these lines. He was convinced that the geometric lines that seemed to flash into focus just for an instant were not natural features, nor an optical illusion, but were in fact artificial constructions, specifically canals built by an advanced extraterrestrial civilization on Mars. And here we can see Percival Lowell seated at his telescope, and one of the images from the collection at the Linda Hall Library of the sketches he made of the lines that he saw through his telescope. Lowell popularized this idea that Mars was home to a civilization of intelligent beings in a series of popular books, including Mars and Its Canals published in 1906, and Mars as the Abode of Life, published in 1908, which were widely read and convinced many that Mars was home to intelligent beings. The Linda Hall Library has copies of these books, which during my residential fellowship in 2019, I enjoyed reading in their History of Science reading room. Lowell's theory gained widespread popularity, and he was a creator defender of it. When astronomers detected an absence of water in spectrographic measurements of Mars, Lowell incorporated this problem into his grand narrative about the canal-building civilization. Well, of course there's no water, he reasoned. That's why the intelligent beings built the canals in the first place, to channel scarce water from the melting ice caps towards their equatorial cities in a desperate attempt to stave off planet-wide drought. For Lowell, the presence of canals explained the absence of water, and he was an expert at spinning any problem and assimilating it into his theory about the civilization. But Lowell's grand narrative pushed even further. He also reasoned that since the apparent canal network spanned the entire planet, the Martian civilization must be politically unified and at peace under one central government. He got all of this whole story, this grand narrative about the canals, about the civilization, the climate crisis they faced, even their history and political structure, all from looking through his telescope, straining at the edge of human perception at a blurry and ambiguous disk that to him appeared no larger than a penny held out at arm's length. And of course, now we can understand why he thought the lines were canals. Back in the late 19th century and early 20th century, there were plenty of canal projects going on right here on Earth, including the Suez Canal, which opened in 1869, and the Panama Canal, which opened in 1914, but was under construction and was a major news story for decades even before that. So this is something that when I think about theories of extraterrestrials, I call cultural tracking. It's when our aliens aren't alien enough. And they really do just come out as a unself-conscious projection of our own technology, of our own body shape, of our own actions and hopes and fears. And Percival Lowell in this way can be seen as a bit of a cautionary figure, not to make grand narratives out of ambiguous and very limited data. I see the same thing happening today with astronomers like Avi Loeb with his ideas about extraterrestrial technologies passing through the solar system, and people who are enthusiasts about UAP culture, the way that they take very ambiguous and limited data and craft a very grand narrative about space exploring extraterrestrials and government conspiracies to cover them up. To me, these are the modern legacies of Percival Lowell. Now, Lowell's idea about an intelligent civilization on Mars was popular in the early 20th century, but not everyone agreed. The loudest criticism of Lowell's Martians came from a surprising source, the British naturalist Alfred Russel Wallace. If the name Alfred Russel Wallace rings a bell for you, it's because he plays a role in a totally separate episode in the history of science, making his appearance in Lowell's story like a kind of historical crossover episode. 50 years earlier, Alfred Russel Wallace became noteworthy as the co-discoverer of evolution via natural selection alongside Charles Darwin. It was Wallace's work that finally spurred the famously reticent and reclusive Darwin to publish Origin of Species in 1859. Now, in the early 1900s, Wallace was well into his 80s and enjoying retirement. But he was so outraged by Lowell's suggestion that there existed intelligent life on Mars that he wrote an entire book refuting these claims. Wallace's book, published in 1907, is titled "Is Mars Habitable?" In the book, Wallace suggests that Lowell is seeing what he wants to see and reading far too much into the limited and ambiguous data, writing, quote, "Years of persistent observation have so completely taken control of his mind." Wallace cited astronomical data about Mars available at the time, showing that not only did Mars lack the water necessary for life, but that it was far too cold to sustain complex beings. Wallace concludes the book, Is Mars Habitable?, by directly answering the question he poses in the title, writing, quote, Mars, therefore, is not only uninhabited by intelligent beings, such as Mr. Lowell postulates, but it is absolutely uninhabitable. And uninhabitable is given in all caps, which has the same meaning back then as it does today. But this debate between Lowell and Wallace was about much, much more than whether life could survive on a freezing desert planet. We turn now to our big question. What does it mean to ask the question, is there life on Mars? What was this dispute between Lowell and Wallace really about? What angered Wallace so much about Lowell's claims that he would come out of retirement at age 84 and write an entire book? It wasn't about the temperature limits of life. It was about something far bigger and more profound. Wallace wasn't a traditional Christian, but he did believe in God. He believed that God created the earth as the center of the universe and that human beings were a special and unique feature of this creation. Wallace believed that humans were the only beings that the Creator had endowed with immortal souls. Lowell's idea of a separate civilization just next door on Mars contradicted this in a fundamental way. How could Earth be the center and humanity be unique if intelligent beings had an even older civilization going on Mars? Wallace perceived that Lowell was writing about the nature of the universe and its creator. Lowell believed in a materialist version of the universe, a disenchanted heavens populated by untold numbers of biological beings and intelligent civilizations. This is why Wallace was so motivated to debunk Lowell's Martian civilization. Wallace believed in an enchanted cosmos centered on humanity, and Lowell's Martian civilization was starkly incompatible with this worldview. Wallace's fight wasn't over whether there is life on Mars so much as his fight was really over the nature of reality. Is that all there is? Matter and motion? Mere materialism, as Lowell's vision seemed to imply? For Wallace, Lowell's positive answer to the question, is there life on Mars, foreclosed on an immaterial, spiritual dimension to reality that he just could not let stand unchallenged. Here we can see how the question of life on Mars can have a strong cultural dimension, in this case, a theological dimension. We can also see how this cultural dimension can change over time. When we talk about the possibility of life on Mars today, no one thinks we are commenting one way or another on the existence of God. These themes are no longer connected with the question the way they were for Wallace in 1907. Now we can turn to our second moment in the cultural history of life on Mars. We jump ahead from Lowell and Wallace in the early 1900s, past World War I and past World War II, to the year 1954. It's the early years of the Cold War between the United States and the Soviet Union. The launch of Sputnik in 1957 and the creation of NASA in response in 1958 are still over 3 years away in the future. In 1954, we are not yet in the space race to land humans on the moon, but we are in the space age, at least the very beginning of it. Even though NASA didn't exist yet, scientists and engineers were preparing for space exploration through military projects within the US Army and the US Air Force. In 1954, the most prominent promoter of space exploration in the United States was Wernher von Braun. During World War II, von Braun had led the Nazi effort to develop the V-2 rocket, the first liquid-fueled intermediate-range ballistic missile, and the first human-made object to reach space altitudes. Despite his connections to the deaths of between 10,000 and 20,000 enslaved concentration camp prisoners who built V-2 rockets inside a hellish mountain factory, von Braun was recruited to the United States at the end of World War II as part of Operation Paperclip. Operation Paperclip was a secretive effort to recruit German experts to work for the US. Over 1,500 German scientists, engineers, and doctors participated, of which von Braun was only the most visible and the most famous. Von Braun and his team of rocket scientists were hired by the US Army and later by NASA and proved instrumental in winning the space race by landing astronauts on the moon in July of 1969. But back in 1954, before NASA was created, von Braun was fixated on sending humans to Mars. From his position in the US Army, von Braun drafted a detailed vision for a human expedition to the Red Planet. And this wasn't just aimed at scientists and politicians. Von Braun was also extremely media savvy. Through appearances in magazines, television shows, and films, we see him here standing with Walt Disney, he became the first modern celebrity advocate for space exploration. His goal was to convince the public that space exploration was not science fiction, but something that could become realistic and happen within the next decade. In fact, in 1954, if you opened the pages of Collier's magazine that we see here, you would be greeted by a popularization of von Braun's plans to send humans to explore the surface of Mars. But Mars in 1954 wasn't Lowell's version of a crisscrossed planet of artificial canals, and nor was it the Mars that we know today as an apparently lifeless desert. By 1954, most astronomers agreed with Wallace's take that Mars was too cold and the atmosphere too thin to support complex animal life. But this did not rule out life altogether. The Mars that von Braun was promoting was a planet covered in vegetation, a green Mars, if you will, which we can see depicted here in this landscape painting by foundational space artist Chesley Bonestell. The idea that Mars supports plant life is actually older than Lowell and his canal builders. And it was actually during my time as a residential fellow at the Linda Hall Library in 2019 that I discovered who first proposed what is now known as the vegetation hypothesis of life on Mars. It was a French astronomer working in Brazil in the late 1860s named Emmanuel Liais, who, looking through a very large telescope, noticed darker regions on the surface of Mars that generations of astronomers before him had previously believed were oceans. Because these dark areas appeared to grow and recede with the seasons, Liais thought a better explanation for these changes was the growth cycle of vegetation. Lowell incorporated this idea into his vision of the canal-building civilization, but when this vision fell out of favor, Liais's older vegetation hypothesis survived and eventually became the mainstream idea of life on Mars in the early space age in the 1950s. And we can see a version of that here on this old trading card, which we can see a sort of natural-looking canal surrounded by that green vegetation. In the 1930s, a Soviet astronomer named Gavril Tikhov first proposed that the type of vegetation on Mars was likely hardy mosses and lichens. On Earth, we find lichens and mosses thriving in very cold, very low-pressure environments, like mountain summits. This is the reason why he thought they were the likely candidate for vegetation on Mars. When Wernher von Braun arrived in the US at the end of World War II, this was the dominant vision of Mars, a planet of plant life. This led some to call it not the red planet, but the green and red planet, which is appropriate for the holiday season. Often, this intermediate concept of Mars as home exclusively to vegetation gets lost in between Lowell's fantastical civilization and our current present-day notion of Mars as an apparently lifeless desert. So when von Braun began promoting the idea of sending humans to Mars in the 1950s, the destination was this version of Mars, the green and red planet. And here we can see a production still from a 1950s science fiction movie set on this version of a Mars covered in plant life. This is a still from the film The Angry Red Planet from 1959, where you can see two astronauts being attacked by a carnivorous plant. But von Braun wasn't motivated by the theological debate between Lowell and Wallace, nor was he motivated by the kind of scientific exploration championed later by NASA. Von Braun was a military scientist, working for a military organization. During a time of heightened militarization, His mission to Mars was one of military conquest as part of the Cold War. When he popularized his idea for a human mission to Mars in books, magazines, films, and TV shows, it wasn't led by a civilian scientific agency. Von Braun thought it would be led by a new branch of the US Armed Services that he called the Space Force. The mission would not be led by scientists, but rather commanded by soldiers. The goal of going to Mars was not to study the lichens and the mosses to learn about life and to learn about biology. It was to demonstrate the technological superiority of the United States military and to take charge of strategic territory. The Cold War saw many of Earth's extreme environments become places of potential conflict, including the Arctic, deserts, and the deep oceans. Von Braun looked beyond the Earth and saw low Earth orbit, the Moon, and especially the surface of Mars as additional places where the US military needed to be able to operate if necessary, and if necessary, defend. How did the question of life on Mars factor into von Braun's plans for military conquest? Since astronomers all but expected to find mosses and lichens growing on Mars, the search for life was not a priority. The presence of life was an assumption. Looking at Mars through a military lens, through a gun sight, if you will, leads to a different way of thinking about any life that may exist there. Military scientists working to support von Braun's vision did not view Martian life as special or scientifically valuable as we do today. Instead, they wondered if it could be militarily useful. Military scientists were hoping to use Martian vegetation to support, in their words, quote, long-term operations of an extraterrestrial exploratory base. This is a biological example of what NASA today calls in situ resource utilization, the practice of generating useful products using local materials. Von Braun's military approach to Mars positions extraterrestrial biology as nothing more than a tool, a natural resource to exploit to help soldiers live off the land. This is a particular way of viewing life that I have called an instrumental regard for life, meaning that you view it only as a tool, something to consume rather than something to study or something to just let live. So what did it mean for Wernher von Braun in 1954 to ask the question, is there life on Mars? For him and the military scientists of the pre-NASA age, it meant, does Mars have natural resources we can use to make the military task of controlling this territory less costly? In this context, potential life on Mars has no theological currency. The presence of or absence of life on Mars had no bearing on von Braun's personal spiritual beliefs. Instead, it had a strategic bearing on plans to dominate and control the Red Planet as an extension of the Cold War. A fitting framing when you consider that Mars is named for the Roman god of war. Our final moment in the cultural history of life on Mars takes place just a little over a decade later, in 1965. We are now on the other side of the launch of Sputnik in 1957. NASA has been created in the name of civilian and scientific exploration, and the space race is in full swing. It's July 1965, and a spacecraft launched by NASA called Mariner 4, that we can see a model of here, is headed towards Mars. The goal was simply to fly past Mars and take basic measurements and photographs. These photographs would be the very first images of the surface of Mars, not taken through an Earth-based telescope. Scientists still expected Mars to be home to vegetation, and some of them even wondered in the back of their minds if the photos would show Lowell's canals after all. The anticipation for Mariner 4's flyby in the summer of 1965 was intense and palpable. If everything went according to plan, some major mysteries were about to be resolved. Mariner 4 snapped 21 black and white photos in total as it passed by Mars. We can see the first of them here. No canals, no vegetation, just a barren, crater-marked surface that looked more like the moon than the Earth. Hopes, expectations even, of finding life on Mars were crushed. Astronomers were genuinely surprised, but no one felt the sting of these disappointing images more than NASA scientists working in a new field called exobiology, short for extraterrestrial biology. Today, this field goes by the modern name astrobiology, but then and now, these scientists were devoted to searching for signs of life beyond the Earth. In 1965, exobiology was a very young field, led by Nobel Prize-winning molecular biologist Joshua Lederberg. And also, it included a very young scientist named Carl Sagan. They faced intense scrutiny and skepticism from scientists in other disciplines who accused exobiologists of wasting taxpayer dollars trying to study something that they can't even prove even exists. They ridiculed exobiology as, quote, a science without a subject. In these early years, exobiologists had immense hope that Mars would deliver a quick win for this new field, that the discovery of life on Mars would yield both drastically increased funding and instant credibility and vindication amongst other science fields. Looking at the photos from Mariner 4, NASA exobiologists knew that keeping their search for life alive would be an uphill struggle. But they had one trick up their sleeve. NASA exobiologists had been experimenting with a device they called a Mars jar. A Mars jar is a small sealed container, often an actual jar, inside which scientists simulate Martian environmental conditions. The thin, carbon dioxide-rich atmosphere, the dry sand, the freezing temperatures. Imagine a terrarium, but instead of recreating Earth, they were attempting to recreate the surface of Mars. In fact, the scientist who invented this experiment first called it a Marsarium. Once the miniature Martian environment was complete, scientists sealed inside different forms of Earth life to see if anything could survive, to see if life was even physically possible under the harsh Martian conditions. What they discovered was that some forms of microbial life, specifically forms of anaerobic bacteria, bacteria that does not require oxygen, were able to survive and even multiply inside the Mars jars. The NASA exobiologists pointed to the microbes living in their Mars jars as a rationale to continue searching for life on Mars. Even though Mariner 4 saw no canals, no vast tracts of vegetation, there's no way that a photograph from space could rule out the presence of microscopic bacteria or other microbes. And so the search for life on Mars shifted once again from intelligent canal builders to vegetation to now microbial life. What did it mean to NASA exobiologists to ask the question, is there life on Mars? For them, this wasn't a theological debate, nor was it a military concern. For them, it was about scientific knowledge about life and about scientific credibility for their new emerging field. They wanted to know, how common is life in the universe? Does life on Mars share a common origin with life on Earth? Is life on Mars made from the same chemical building blocks as life on Earth? How is it able to survive under such extreme conditions? But perhaps just as much, they wanted to be taken seriously. For NASA exobiologists, the search for life was also a search for credibility. In 1976, NASA sent two landers called Viking 1 and Viking 2 down to the surface of Mars. These stationary vehicles couldn't move around like modern rovers and drones, but they did carry life detection experiments to test the Martian regolith for signs of microbes. The experiments produced inconclusive results that were eventually interpreted as negative. I love to show this picture from one of the Viking landers because it shows a sort of frosty Martian winter scene. Today, the scientific search for life on Mars, using orbiting spacecraft and surface rovers, including NASA's Curiosity and Perseverance rovers and the Ingenuity rover copter, which we can see here, has been scaled back from a search for life to a search for what they call past habitable conditions. The most realistic chance we now have of finding evidence of life on Mars would probably be some kind of fossilized microbe from the ancient past when Mars was warmer and wetter. But still, as of tonight, there is no evidence for life on Mars, past or present. But both Mars and life itself have consistently surprised us. So we should remain humble and see where the search leads us. The question of life on Mars today is mostly a scientific one. But as we have seen, what it means to ask the question changes over time. So we should anticipate future changes as well. On January 15th, a little over a month from today, Mars will come into opposition with Earth. This age-old orbital cycle, which for centuries has regulated our scientific and cultural interest in the red planet, will again come full circle. Mars will be easy to spot in the night sky, and hopefully it will still be on your mind then after our lecture tonight. But just as we have seen how the question of life on Mars has been given shape by cultural frameworks, including theology, militarization, and science, we are again at an inflection point where the question of life on Mars is changing. The idea that Mars is primarily a place for scientific research in planetary science and astrobiology is facing a challenge from new actors who believe Mars is a place for commercial human settlement. This would again change the cultural framing of the question, is there life on Mars? Companies like SpaceX might actually try to do the opposite of what the NASA exobiologists were doing and try to prove that Mars is totally sterile and that Mars has never been home to life. This would make their plans to construct a million-person city on Mars all the more easy to carry out. For them, the question of is there life on Mars is really a question about possible barriers to commercial development and large-scale construction projects. For them, the discovery of microbial life surviving in a niche microenvironment or a fossil of a long extinct life form from ancient Mars would be an inconvenience, a barrier to plans to establish a settlement and perhaps terraform the planet. So the next time you hear someone talking about life on Mars or life beyond the Earth in general, I hope you will remember this lecture and ask, what are they really talking about? Thank you all for listening tonight. And thank you very much to Eric Ward for inviting me to give this lecture tonight. And thank you to the entire team and staff at the Linda Hall Library, especially Ben Gross and Jason Dean for their incredible research experience they provided me in 2019. So much of this talk and so much of the courses I teach at the University of Chicago draw on the materials I was able to work with at the Linda Hall Library. I am so grateful for the library's existence. It's a true treasure, and I'm thankful to be part of the extended scholarly community. Thank you very much.
Dr. Bimm, that was a wonderful lecture. Thank you so much for that.
You're
And
welcome.
if anyone has a question, you can type it in the Q&A chat box you see at the bottom of the screen, or you can drop it in the chat there as well. If you're watching on YouTube, type your question in the chat and we'll get it to our speaker. We're getting a lot of people saying thank you and very interesting and informative. Thanks, Jordan. That was excellent. I love those old 1950s illustrations, from the Collier's magazine and some of the Chesley Bonestell artwork as well. I think it really captured the imagination of people back then of what Mars could be. All right, we have a
Absolutely. Yeah, go ahead.
no. Go ahead. Go ahead.
I was going to say that those paintings, they really draw on the style of German Romantic landscape paintings, the kind we see from Caspar David Friedrich and Albert Bierstadt, and they really did, shape the expectations of what it would be like to stand on another world.
Right. There's a question about will the recording be available? Yes, it will be. It's we are actually live streaming not only via Zoom but on the Linda Hall Library's YouTube channel. So that recording will stay up. It's available now on the YouTube channel. So certainly as soon as the program ends, if you want to rewatch it, and I encourage you to do so, just go to our YouTube channel. I also forget that we had a lander on Mars in the 70s.
Yeah.
The Viking landers. That was 1976. Like, wow, that was what 4 years after the final Apollo mission. So that was pretty quickly after the moon landing. I mean, it wasn't the Vikings didn't have landers didn't have humans, but still, that was uh, it's a long time ago now.
Yeah, those images are just so fascinating to look at, given how old they are now and what they
Yeah,
actually show us. What's interesting is that the Viking life detection experiments, because they produced negative results, it actually led to a 20-year gap in Mars exploration. We didn't start sending spacecraft to Mars again until the 1990s. And some of you might remember in 1996, there was a meteorite that was from Mars that some NASA scientists believe might contain a fossilized bacteria. It turned out later on to not actually be a fossilized bacteria, but that press conference and that big announcement generated renewed interest in
a lot
searching
of
for life on
buzz. Yeah.
Mars. Yeah, that we are still kind of riding that wave today with rovers like Curiosity and Perseverance.
Right. We have a question from Al who asks, have they only searched for carbon-based life? Any scientific inquiry about alternate forms?
So, from the very beginning of the field of astrobiology, we have tried to think outside of the box, outside of life as we know it. Of course, we are limited to, n equals one. Life on Earth is really the only example that we have. But chemically, we can imagine other types of life that don't use carbon, but say use silicon. We haven't actually searched for that type of life. It's been mainly theorized. There have been some searches on Earth for exotic types of microbial life. You might remember in 2011, there was an announcement about the possibility of a form of life that uses arsenic instead of phosphorus. This turned out to be an incorrect finding, but it shows that we are looking for life that is kind of outside of the box, that is different than life as we know it.
Right. Charles comments that Carl Sagan was adamant that even if microbes were discovered on Mars, then we should do nothing there. Charles says, I think that's a sound policy, but how could that be done today? And that gets into international policy about space travel. Has there been any cooperation with policy decisions like that?
I mean, growing up, Carl Sagan was an inspiration to me. I was that kid riding the subway to high school, reading the Cosmic Connection and Cosmos, before going to class. And now as a professor at the University of Chicago, Carl Sagan's alma mater, I feel a special connection to him. And so I agree with his sentiment. And when I talk about something like the instrumental regard for life that the militarization of Mars kind of gave us in the 1950s, this is what I'm trying to drive as is that even in our scientific moment today, we still kind of have that instrumental regard for life, that we kind of have a right to do whatever we want to that life when we find it, whether it's study it or consume it or whatever the case. So when Carl Sagan said if we find microbes on Mars, that we should let them have that planet, that it should be for them, I kind of agree with that. There are ways that we could study that life remotely, but in terms of stopping activity on Mars today, when we have a host of international actors at the planet, it's not only NASA anymore. China has landed a
Right.
rover, the Zhurong rover. ESA, the United Arab Emirates, India have spacecraft in orbit. So it really is open. There is no international law, governing this aspect of scientific exploration and the protection of potential microbial life on Mars. The saving grace is, I think, Mars is probably lifeless.
All right. Another question is the exploration of Mars. Oh, I lost the question here on the screen. Is the progress of exploration of Mars, uh, or what's the progress of the exploration of Mars? Have we covered 50% of it? Or is there a specific goal? I assume we have a lot of territory, a lot of a planet hasn't been looked at yet very closely.
Exactly. So we have orbital photography of the entire planet. Like we have like a Google Earth of Mars, but we can't see, with much detail. We really have to use those rovers if we want to get detail. And you might think because rovers have wheels that they drive fast around Mars and they cover large distances. That's not true. They move so slowly and they cover a fraction of 1% of the surface. And in fact, NASA has intentionally limited the rovers and landers to places on Mars that are actually not good candidates for life. Both because, first of all, they didn't want to land in any places that were difficult and could damage their landing vehicles. They wanted to land in a very boring, very easy place. And
Sure.
also because spacecraft are improperly sterilized, they're not 100% free of Earth bacteria, perhaps. We want to avoid the possibility of contaminating a microenvironment on Mars. So there are certain areas that rovers are actually not allowed to go according to NASA's own rules. Other countries could definitely break those, but we have a sort of system in place that says we've only explored a small amount of Mars and that there's so much left and so many other places to look that it wouldn't surprise me if we did find, life hanging on somewhere in some sort of obscure microenvironment or perhaps subsurface under the surface of Mars in one of those
Hmm.
pockets of liquid water that's recently been detected.
Do you have any updates on the chances of the sample return mission becoming a reality?
Yeah, so this is every spacecraft that we have sent to Mars has stayed there. Nothing has ever brought material back to Earth. And so that's been a project that NASA's been working on for decades now, is to have a robot go to Mars, scoop up some of the regolith and rocks, and blast it off the planet back to a laboratory on Earth. Right now, we have the rover Perseverance on the surface collecting samples and putting them in little test tubes with the hope that a future spacecraft will return those to Earth. Unfortunately, the funding for the Mars sample return mission has recently come into question. And with the change in administrations happening right now, it's a really bad time to make any predictions about what NASA might or might not do in the future. All I can say is that the astrobiology community really, really, really wants there to be a Mars sample return, but they don't want the cost of that to overwhelm other missions to places like Jupiter's moon Europa or Saturn's moon Enceladus.
Well, you mentioned those other planetary bodies in the solar system. Where do you think the best chance there is to find life in the solar system? Would it be one of the moons of Jupiter or Saturn? Is
I
that
mean,
kind of the latest thinking?
it is, yeah. So for a long time, we thought Mars was the best candidate to find life, and we still may find it there. But there are these emerging areas of astrobiological interest. The icy ocean world moons of Jupiter and Saturn, Europa and Enceladus, are two examples. Titan is also of interest, and the thinking goes, follow the water. So on Earth, wherever we find water, we find life, and we think that those icy ocean world moons have liquid water underneath their icy crust, and so we want to know whether or not the conditions inside those sealed water environments would be conducive to life. That's what spacecraft like the Europa Clipper, which launched just a few months ago from Cape Canaveral, that's what it's on the way to find out, to see whether or not the conditions there are habitable. And then maybe a future spacecraft would then search for life. Now, a related question is whether or not it's more likely we will find life somewhere in our solar system, or we will first detect it perhaps in an exoplanet, which is a planet around a sun other than a star other than our sun. And we will soon have instruments, space telescopes, that will be able to measure the chemical composition of exoplanet atmospheres. And the composition of gases there may give us an indication that some sort of biological reaction activity is happening on that planet. So that might be the first place that we detect life outside of the Earth, and not in our own solar system.
It's an exciting time to be an astronomer.
It really is. And, let's see where the next decade takes us. I'm incredibly excited. The work I do with NASA's astrobiology program and with the SETI Institute is geared towards this. And I remain optimistic, but also humble towards the mystery of the universe. And we should never take anything for granted, and we should let the data, guide us in terms of our conclusions.
Let me ask you this. We're approaching the top of the hour. Let me just ask you a couple fun questions, I guess. How long do you think it'll be before we detect life in the universe?
I mean, that's one of those. This is why I study this topic. It's so exciting, and it could at any moment, even the James Webb Space Telescope right
Right.
now, could perhaps, at the outside range of its capabilities, give us an indication of a biosignature around an exoplanet atmosphere. So it could happen tomorrow. I think
That would be exciting.
that
Yeah.
would be so exciting. I would instantly have to go to work, but it would be super exciting. I think we have a really good chance in the next decade to 15 years. That's the sort of time range that a lot of scientists I work with are speaking in. But we should never speak in inevitabilities. We should never assume that this is going to happen, and we should never take anything for granted.
Sure. How long do you think it'll be before humans set foot on Mars? You have a question about SpaceX there.
Yeah, I think
Uh,
SpaceX is probably the most likely entity to send humans to Mars.
you
It's
think they'll do it before NASA or
I think they I think
China
they
or someone?
I think they will do it before NASA if anyone does it. I think it's probably
Interesting.
prudent to first do a flyby mission that doesn't land on the surface. I'm a big promoter of this type of mission model in which astronauts in a spacecraft orbit Mars and then return to Earth without landing on it. I think that's a very prudent first step. It would be a long, 2-year mission because of the opposition, but I think it would give us a lot of information and it would be a good trial run before trying to do the whole shebang of, entry, descent, and landing onto Mars with human beings. So,
And
you know,
Apollo did that.
Apollo did do that. The moon was
Yep.
much closer and much easier. No atmosphere to deal with there, and 4 days, versus 6 to 8 months. But I think it's realistic to think maybe in the next 10 to 15 years as well is when humans might make it to Mars. But once again, I think we should never think of it as an inevitability. We should think of it as something that's possible, but only if we choose to do it.
Right. I would love to see that happen. That would be just fantastic to follow along with those missions. But it would be a long time, right? Like going to the moon, it's 3 or 4 days to get there, but it'd be a long wait
It
as the
would. It would be an
as
exciting.
yeah, as the spacecraft travels there and back. So
Hmm.
it's fun stuff to think about. Well, Professor Bimm, we are a little past the top of the hour, so we'll conclude the program. Thank you so much for your lecture this evening. I learned a lot, and I'm sure everyone else did too. We'll have to do it again sometime.
That'd be wonderful. Thank you very much. I had an excellent time tonight. Thank you.
And thank you everyone for attending tonight's program. For more information about all of our upcoming events at the Linda Hall Library, visit lindahall.org. Also, when you visit our website, please also visit our Linda Hall Library Foundation. Your contributions make all of our programs possible and freely available. So thank you again, Dr. Bimm, and thank you everyone, and have a great